All right, so this is our first lessons on electricity and magnetism for year 11. Okay, um, so the first lesson is about electric charge and current. So possibly you have learned electric charge or current before. So you see, for this video, there are lots of things about the revision. We recall a lot of facts you might have learned in previous years, right? Okay, so let's have a look. Okay, the first thing is about charge and charge carriers. Okay, so normally when we say electron is a charge, okay, it is not entirely wrong because everyone understand what does it mean, but actually electron is a charge carrier, okay, and the charge you carry is another quantity. Okay, so when we call charge, it's not a thing, it's actually a quantity. All right, it's not a particle. Right, so let's define the electric charge. So electric charge is what kind of property of many subatomic particles. Okay, the most famous subatomic particles with charges are electrons and protons. Okay, right, so we use symbols like this. We use symbol like this. Proton, we write P plus. Okay, so charge is what we call a fundamental property of these subatomic particles. Okay, what do we call them? Fundamental properties. Something that when you describe a subatomic particle, normally you need to mention. Okay, for example, when we describe electron, you say, okay, its charge is -1 unit, and its mass, okay, is a very small number. Okay, and proton, you would describe it as a +1 unit in charge, and its mass, okay, is about the mass of a hydrogen, etc. Right, so possibly, when we describe things, we use some fundamental properties to describe something, and electric charge is just one of them. Okay. Okay. So charge is also a characteristic matter that's referred to extent which a particle have fewer or more electrons and protons. So when we see some ions, for example, when we see calcium, if you study chemistry, you know that's the charge of calcium ion should be 2+ units. So that's 2+ units means you have 2 more protons than electrons in that calcium ion. Okay, so that's 2+. So if you got fluoride, which is minus, right? Fluoride ion. So this time you got 1 more electron than proton. Okay. Okay. Second one is very common, so you should understand. Charge can either be positive or negative. You understand this? I don't need to mention that, right? So, and like charge repels and like charge attracts. These are very basic idea. And the size of the force, when we call their repulsion and attraction, that means they are forces, right? So the size of the force depends on the size of the charge and their separation. So we are going to learn that in our Unit 3, so but now you just have some idea about it. Okay, okay, so how about charge carriers? Charge carrier are particles which carry net charge Okay, so why do we invent such a term called net charge? Okay, for example, if you study chemistry, you should understand that. For example, if I got for example, sodium. Okay, sodium. Okay, so what would be our possibly I make a easier one. How about lithium? Okay, so lithium we've learned that lithium is like you got got 3 protons and normally got 3 neutrons. So that would be lithium, right? So that's a lithium atom. So in a lithium atom, there are 3 protons and 3 neutrons. Okay, so if that's a lithium atom, so the net charge is 0. That doesn't mean lithium has no charge inside, but the charge of electrons and the total charge of proton, they are balanced. So you don't see you don't see a net charge. But if lithium it lost 1 electrons, then it becomes lithium plus. Okay, lithium plus ion. So this time it still got 3 protons. We know that it still got 3 protons. Okay, 3 protons. Okay, but since it lost 1 electron, become plus 1. Okay, so right now you got 2 electrons. Okay, so these are very basic chemistry knowledge, and you should have learned in previous science lessons, right? So in this case, net charge would be positive 1 unit. So in chemistry, you just call positive 1 unit, right? So in physics, we call positive 1 E. E means electronic charge, but it's positive 1 E. That means because it got 1 more proton. So that's the way we talk about net charge. Okay, so so sometimes we are lazy. We just call something carry a charge. So when we call something carry a charge, normally that means carry a net charge. Okay, so if you answer the question, you don't want that kind of confusion, you should write carry net charge rather than just carry charge. But you need to understand, sometimes when you see YouTube or you even in the textbook you see something carry a charge, that means net charge. Okay, so if there's a positive charge carrier, that means in that charge carrier it could be ions, could be electron, proton. Okay, so the number of electron less than proton, and negative is just the opposite, right? So I'm not going into detail, you should understand. Neutral particle carry no 0 net charge. Okay, that would be very common knowledge as well, so I'm not going into details. Alright, so measuring charge, so how could we measure charge? So that's pretty new for some of you possibly. Measuring charge, so that means we need to give a quantity for the charge. Okay, so if you want to quantify charge, you need to give it a unit, and for charge the unit is coulomb. The common constant used for charge is, okay, so this is what we call elementary charge. So elementary charge is what we call electronic charge. It's the charge carried by, if it's positive 1 E, charge carried by 1 proton. If negative 1 E, charge carried by 1 electron. Okay, so 1 E, 1.6 times 10 to the power minus 19 coulomb. Okay, use this unit to describe charges. It's 1.6 times 10 to the power minus 19 coulomb. Okay, so but that's for charge carried by 1 proton. Okay, so if that's the charge carried by one proton, therefore the charge carried by one electron is minus E, which should be this one. Okay? Okay, calculate the charge in coulombs, okay, carried by 1 million of proton. Okay, so you need to calculate the charge. Okay, charge in physics, normally we use the symbol. Sometimes you use symbol capital Q or lowercase q. It depends on the textbook. In this textbook, normally they use lowercase q, right? Okay, so how could we calculate the amount of charge? Okay, so that's 1 million of proton. So each proton carries 1 electronic charge. 1 million, so million means 1 times 10 to the power 6. Okay, so the total charge here, we're going to use 1 times 1.6 times 10. Oh, sorry about this. I possibly to write the symbol first. Okay, million in scientific notation, which usually we use big M. All right, so that's million. And so that will be 1 times 10 to the power 6. Okay, and times E. Okay, so if you use your calculator correctly, it will be column. Okay, so how about billion? So billion will be 1 times 10 to the power 9. Right? Okay. And for this one, let's just go, but that's electron. So it should be negative, right? It should be negative, all right? Okay. So it should be 1 minus 1 giga, okay. Minus 10. Okay. If you want to track this medium giga, you might go to a website to track. Okay, normally it's a very common notation. Okay, if you don't want to memorize these letters, that's okay. Just go directly. Millions 1 times 10 6, billion 1 times 10 to the power 9. You should know this already, right? Alright, okay, so trillion. Okay, trillion is 1 times 10 to the power 12. Okay, alpha particle, what do we mean by alpha? So if you understand alpha is, normally we write, there are 2 ways to write it. One way is write alpha, when you understand 2 plus. Okay, or sometimes you just write the helium, because of helium nucleus. Okay, so 2 plus here means that's plus 2 electronic charge. Okay, so that's 1 trillion electronic charge. So that will be 1 times 10 to the power 6. Okay, oh sorry, I make a mistake again. Sorry. It's actually not E, it's 2E, right? Because each alpha you carry 2 plus, it's not just 1. Alright, so you will got it as 3.2 times 10 to the power minus 7 column. Alright, so no problem. Okay, so the other type of question is number of the specific charge carrier for each of the following amount of charge. So they give you the amount of charge, and you are going to find the number of charge carrier. So this is the charge, the total charge. Okay, so you need to find number of beta positive. What do we mean by beta positive? Okay, so if you still remember, we've learned beta positive. It's actually just, so sometimes you write beta positive, right? Or it just E plus, that's a positron, or what we call positive electron, if you remember. Okay, so let's say number, we don't know how what's the number. Let's say it's n. Okay, so number of beta particle, number of beta positive particle, which amounts to 1 coulomb in total charge. So that will be n times E, because each beta plus carry E charge E, right? Okay, equals 1. Okay, well, I should just write Q, it would be easier for you. Okay, so that's 1. Okay, so in this case, you just divide the whole thing to the other side. So it should be 2.625. So that will be number of beta plus particles. Okay, so this question you won't see. I'm not quite sure about, but it's not an example similar to the sorry, I should say the previous example is not the one you will see in the textbook. So for those textbook lovers, sorry, you might just skip 2.1. If you're really keen on follow everything on the textbook, that's up to you. But I do think you need to know to calculate both ways, right? Alright, so number of electron for minus 0.01 coulomb. Okay, so it will be the same way to do it. So can you try it now? So I'm going to give you some time, right? Okay. Okay, so if you use calculator correctly, okay, so that will be the answer, right? Okay, so here's one example in the textbook. The net charge on the object. Okay, so you see the net charge is minus 3.0 mu coulomb. Okay, so that's mu. That's what we call the pronunciation is a Greek letter. It's called mu. All right. So if you know, it should be 10 to the power minus 6. Okay, so calculate the number of extra electron. Number of extra electron. What do you mean by extra electron? Okay, because we know electrons minus E, and the net charge is minus. So let's go back to previous a previous thing. Charge is a characteristic method that refers to the extent which a particle has fewer or more electrons. So if you got minus, okay, so that means you got more electrons than protons. Okay, so that's why if you got minus, that means you got extra electrons in comparison to the number of protons in the nucleus. Alright, okay, so let's need to do it. Alright, so I might give you some time. You might pause the video. Yeah, so let me show you the answer from the textbook. Okay, so first the charge is, sorry, not this one, sorry, I think I made a mistake here. Okay, don't worry, I just search another way. Okay, just give me some time. Okay, I just found that the textbook make a mistake here. Okay, so the question should be the net charge minus 3.0. The textbook got minus 4.8. So yeah, we all understood what happens. So the question just like this. If you got the answer, then that's all good. Okay, so that's all about charges. Let's move on to current. Oh, okay, before we move on to currents, remember do some questions. Okay, so you don't need to do all the questions in the book because there's some sections, some content in the textbook. I don't think they belongs to the curriculum from QCAA, so we don't need to study them, right? But if you are interested, you are welcome to read them from the electronic book I share with you. Alright, but I don't think if you are tight with your studying schedule, possibly you should skip them. Okay, so that here are the questions I selected for you. Alright, so let's see some electric charges. Okay, so sorry, it's not electric charges, it's electric current. Okay, so electric current is about the flow of electric charge. Okay, so you could kind of think of electric current is the flow of a lot of charge carriers which have charges, carrying charges. Alright. Okay, so for a current to happen, there are two things. First, you need to have charge carriers, or more precisely, you need to have free or mobile charge carriers. And the pathway, that means you need to have complete circuit. So for complete circuit, if you want to define more in more detail, it should be from or between a pathway between positive and negative electrodes. So so all the circuits, you must have source of electricity, right? Could be a battery, could be a generator, but for every source there should be two terminals or two electrodes. Okay, so for a complete circuit, that means you have a path to link between that two electrodes. Okay, so there are some very common charge carriers which can create the current. For example, the electrons in metallic wiring, okay, or mobile ions in electrodes. Okay, so if you don't know what do we mean by electrodes, you might ask your chemistry teacher or go to the internet to see it's an aqueous with some ions, but I can't go into details, right? Although electrons are the only moving charge carrier in metallic conductors. Okay, so here, so we all understood that electrons are negative. So if there's a pathway between the negative terminal and the positive terminal, okay, so electron will go from the negative terminal to the positive terminal, right? Because it's negative, so it will leave the negative terminal and go to the positive terminal. Okay, so you can understand this because for a battery, you got two electrodes. So when the electrons are on the negative terminals, they are being repelled, all right? So they have to go to the other electrode, which is positive, which is attracting them. If there's a pathway, then they are going to cross the pathway to the positive terminal. That's what happens. That's for a current. So electrons from negative terminal to positive terminal. So if we look at the nature of the charge carrier of electron is negative. So normally we should say the current in the metallic conductors, okay, should be negative, right? But in all the textbook or in our scientific conventions, the conventional current is always positive. Okay, so it's very interesting. Okay, so the actual flow of charge carriers are negative, all right, because electrons are negative. So the actual current should be from negative to positive. That's what really happens. But in science or in physics, we will always treat current from positive to negative. We always assume currents are formed by positive charges, even though there's no flow of positive charges. So that's why we call it conventional current. It's just like the current that everyone agrees on, but everyone knows it's not happening in many cases. Okay, so the reason for having that kind of confusion is in the past, the scientists once mistook the charge carried by electrons positive. So around 120 years ago, so scientists at that time, they thought electrons were positive. So that means from that time they regarded that current flow should be positive, but actually it's not the case. Okay, you need to understand that. You need to understand when we draw current, it's always positive to negative, but you also need to understand the actual current flow. In most of the circuit, in 99% of the circuit, should be from negative to positive, right? That's what we call the actual current. But the conventional current, the current we draw, is from positive to negative. All right, that makes sense? Okay, so another law I'm going to introduce, and which you should have learned before, is the law of conservation of charges. Okay, electric charge cannot be created or destroyed, and is always conserved. It's a bit like the energy. So there are two most famous laws of conservation. One is the conservation of total energy. The other is the conservation of the total charge. Okay? Electric charge cannot be created or destroyed and is always conserved. Okay, so that's the idea. Okay, so what's so important? Okay, so for example, if I got plus 2 column, plus 2C here, and also I got, okay, minus 1C. Okay, so when both are conductors, okay, so let's say if they touch, what happens? Okay, so I try to copy it. Okay, I'm going to copy this. So after they touch, suppose, so because that's positive 2C and minus 1C, when they touch, so they neutralize. So the net charge will become positive 1C, right? But since if I know I mean if, so it's just randomly taken, right? So if I know here is 0.7 coulomb, so what will be the charge on here? Okay, so let's say the charge on here is Q, which we don't know. Okay, so you can always apply the law of conservation. Okay, so the law of conservation means plus 2C plus minus 1C will equal 0.7C plus Q, and that Q will be 0.3C. Okay, so that's how we use the law of conservation. All right. In the circuit, the total amount charges are always constant. Okay. So that means in the circuit you got lots of electrons. For example, you got lots of electron carriers. Okay, and each electron carrier they carry 1.6 times 10 to the power minus 19 coulomb, right? So there are total amount of charges in the circuit, and this amount of charges won't change. But the current can be changed. So the law of conservation doesn't mean the current cannot be changed. Current can be changed, but the total amount of charges cannot be changed. Okay, so there are two different things, right? Charge is about the fundamental property of each charge carriers, right? But the current is about the flow of charges. You might not have the flow of charges, but the charges are still there. All right. Okay, so that would be the idea. Okay, so let's have some formula to calculate the current. Okay, for the calculation of current, is I equals Q over T. So that's what we call the definition of current. Okay, so you can't. Sorry, of course, for some of you, possibly you'll be happy with just remember I equals Q over T. But for better understanding, you should remember this formula as current defined as amount of charge flowing through 1 point per unit time. Okay, so there are several things. So current is measured at what? Certain point. 1 point. So at different points, current might be different. Okay. So and also it's about the charge flow per unit time. So it's Q over T. All right, and you need to be aware of the units as well. Okay, for Q. Okay, the unit will be coulomb. T will be second, and I is a unit called ampere. Okay, possibly you have learned that before. If you haven't, you need to know it now. So it's an ampere. Okay, so 1 ampere equals 1 coulomb per second, because that's when you consider Q is one coulomb times 1 second. 1 coulomb over 1 second will be 1 ampere. Okay, so that's the way we define 1 ampere. Okay, so again, for better understanding, okay, you better understand that 1 ampere means 1 coulomb of positive charge passing through a point 1 second. Okay. So this will be the very basic calculation in the examination will be just apply understanding. Okay, so the easiest mark to get. Calculate the amount of charge and the number of electrons passing through a point in the circuit. Okay, so it's about the charge. Is Q. Also, you need to find number of electrons is what we call N. Okay, where the current 2A in 1 minute. So possibly you are given current, also you're given time, and of course because we know for current, the unit for time is seconds, so I need to change 1 minute into 60 seconds. Right, so let's say when we use the formula, it's like this. So from this formula, you could find the current. You could find the charge Q. Alright, so current 2A, Q is what you are going to find, T is 6 seconds, so you multiply that. Okay, so it's 120 coulomb. So how many electrons in that 120 coulomb? Okay, so still remember this, number of electrons times electronic charge. Okay, I'm searching the answer, right? Give me a minute. Okay, so the answer would be just 27.5 times 10 to power 20. Okay, so there'll be number of electrons. Alright. Okay, 0.1 coulomb passing through a point on a wire 2 seconds. Calculate the number of electrons. Okay, so this time you need to find the number of electrons given what? Given charge, okay, and given the time. Okay, so here's the charge, it's the time, number of electrons passing through the point, and then you are going to find the current. Alright, so let's do it. So number of electrons, 0.1. Okay, so let me write more properly. Okay, second one, you need to find the charge. Okay, sorry, you need to find the current, so the unit will be ampere, right? Okay, so try yourself for this one. Okay, you might go to for okay, so I just try to change the answer from the book a little bit, so it will be more consistent with what I'm doing. Okay, so you see the answer will be like this. Okay, so that's it. Okay, so again, there are some questions for you to try. Okay, let me say again, I'm not asking you to try to do all the questions. But I'm not going to limit how many questions you are going to do. If you really want to have a very good grade, you need to do all of them. Okay, let's be honest, because that will be always helpful if you can do more. All right, so because that's for the university entrance examination. All right, it's not a school-based assessment. All right, so but if you can't do them more, that's all right. That's completely fine, as long as you have tried some of them. Okay, it's your individual choice. I'm not going to force anyone to do more than that, to do more or less. There's no point to do it. Okay, so it's up to your decision. Of course, I don't want to destroy your life-work balance. If you need to have a break, you could have a break. You could do it later, you could catch up, but you need to have a certain discipline for any serious study. All right? Okay, that's my advice anyway. Okay, we'll see you next time.